What if space started closing in, literally? From galaxies squeezing together to the laws of physics flipping upside down, today we're diving into the wild science of a shrinking universe. Buckle up, because reality's about to get weird. Right now, our universe is doing the exact opposite of shrinking. It's expanding and fast. Every second, galaxies race away from each other at mind-boggling speeds. Some are moving away from us faster than the speed of light itself. This expansion is driven by something called dark energy, a mysterious force that makes up about 68% of everything that exists. We discovered this expansion less than a century ago, thanks to astronomer Edwin Hubble. He noticed that light from distant galaxies was stretched or redshifted, proving they were moving away from us. But what if this expansion suddenly reversed? What if gravity finally won the cosmic tug-of-war and started pulling everything back together? This scenario is called the Big Crunch, essentially the Big Bang played in reverse. For this to happen, the universe would need to be dense enough for gravity to overcome dark energy's push. Scientists call this the critical density. Think of it as a cosmic tipping point. Current evidence suggests our universe isn't dense enough for a big crunch, but let's imagine dark energy suddenly weakened or disappeared entirely. The first sign wouldn't be visible to the naked eye. The cosmic microwave background, the afterglow of the Big Bang, would start to blue shift instead of red shift. Astronomers would notice distant galaxies appearing to slow down, stop, and then start approaching us. The Hubble constant, our measure of universal expansion, would flip negative for the first time in cosmic history. As contraction accelerates, space itself would begin compressing. Distances between objects would shrink, even if they weren't moving. Galaxy clusters, the largest structures in the universe, would start merging at an unprecedented rate. Our own Milky Way, currently on a collision course with Andromeda in 4.5 billion years, would face this fate much sooner. As galaxies merge, their gravitational dance would fling stars out of their orbits, creating cosmic chaos. The supermassive black holes at galactic centers would spiral toward each other, creating gravitational waves that would ripple through space-time. Ironically, all this galactic violence would trigger an explosion of star formation as gas clouds collide and compress. But these stars would live fast and die young. The increased density would accelerate stellar evolution dramatically. As the universe shrinks to extreme densities, the fundamental forces of nature would begin to merge back together. First, the electromagnetic and weak nuclear forces would unify, just like in the early universe, but in reverse. Quantum effects, normally confined to the subatomic world, would start influencing objects on larger and larger scales. Time itself would become unreliable. Different regions of space would experience time at different rates as gravitational fields intensify. The normal flow of cause and effect might break down entirely in some regions. In the final billion years, the cosmic microwave background would heat up dramatically, eventually becoming hotter than the surface of stars. Stars would begin to evaporate as the background temperature exceeds their surface temperature. Eventually, it would become so hot that atoms themselves would break apart, returning matter to a primordial plasma state. In the final moments, we'd approach what physicists call the Planck epoch, the same conditions that existed in the first fraction of a second after the Big Bang. All matter, energy, space, and time would compress into a single point, a singularity where our understanding of physics completely breaks down. Some theories suggest this wouldn't be the end, but rather a new beginning. The Big Crunch might trigger another Big Bang, creating a cyclic universe. Others propose that our shrinking universe might be just one bubble in an infinite multiverse, with countless other universes expanding and contracting. Quantum mechanics might prevent the formation of a true singularity, causing the universe to bounce back into expansion. The truth is, we're still learning about the fundamental nature of space, time, and gravity. Future discoveries in quantum gravity and cosmology might completely change our understanding of what's possible. Here's the reassuring news. All current evidence suggests our universe will keep expanding forever, not contract. In fact, the expansion is actually accelerating, driven by that mysterious dark energy we mentioned earlier. Instead of a big crunch, we're more likely headed for a heat death, a cold, empty universe where all the stars have burned out. But exploring scenarios like the Big Crunch isn't just science fiction, it's how we test our understanding of the universe. By imagining extreme scenarios, we push the boundaries of physics and discover new insights about reality itself. So while our universe probably won't start shrinking anytime soon, imagining it helps us appreciate the incredible cosmos we actually live in. It reminds us that we're part of something vast, dynamic, and still full of mysteries waiting to be solved. Every day, scientists are uncovering new secrets about dark energy, dark matter, and the ultimate fate of everything. The next time you look up at the night sky, remember, you're seeing a universe that's been expanding for nearly 14 billion years, and will likely continue expanding long after we're gone. And that's pretty amazing, don't you think?